Welcome to this instructional video to demonstrate the application of using the ABB Microflow as a remote transmitter, or as we call it, an XMV. In this video we're going to explore the configuration and setup of the Microflow in a multi-tube AGA3 configuration. Let's take a quick look at an overview of the Microflow hardware. As we open the case, we have a display connected with a ribbon cable to the main board. On the main board we have a daughter card, which can be either RS-45 or RS-232. In our case it'll be an RS-45 board. To the right we'll see the RTD temperature connections. And down below the unit will house our ABB transmitter. Let's first take a look at our hardware requirements for the project. Looking first to the XFC board, the G4, we're going to need to put an RS-45 module in the communication 2 slot on the board. As you can see from the diagram, we can attach the module to the board in this fashion. Next, let's take a look at the Microflow. We'll of course need the main board, and the daughter card will need to be placed on the main board. As you can see here, we'll need the RS-45 configuration of the board to talk to the XFC G4. And finally, of course, we'll need an interconnecting cable, a RS-45 cable, to connect between, as you can see in the diagram, the main XFC board and the Microflow. We'll need a ground, bus plus, and bus minus. As you can see in this diagram, the configuration we will set up today involves one XFC G4 as the master, one Microflow as the slave, and both units will be connected with an RS-45 cable via COM2 on the XFC. The XFC G4 will have two AGA3 measurement applications set up in its configuration and will be responsible for calculating flow and storing data for both AGA3 tubes instantiated in the XFC. The XFC G4 will also supply the 12-volt DC power to the Microflow if there's no power supplied on the Microflow itself. The G4 will also supply display data via the RS-45 link back to the Microflow for its display. The first AGA3 measurement application will get its inputs directly from the XFC's own onboard transducer. The Microflow will have the singular task of sending live readings of differential pressure, absolute pressure, and temperature to the XFC for the AGA3 measurement tube number 2 calculation. No AGA3 calculations are being performed in the Microflow itself. As you can see from the diagram, I've got the XFC board on the bottom, and towards the top I have the Uflo represented. We're going to need basically 3 wires, connect a ground between both units, connect bus plus, and connect bus minus. Let's start our PCCU configuration with the XFC board. We'll first go in and connect to our board as normal. Go to the top level menu. We need to instantiate another AGA3 application. Go down and turn on another measurement tube, AGA3 measurement tube, in application 12. We'll send that. Besides the second AGA3 tube, we also need to make sure we have an XMV set up in the G4. As you can see, I already have one set up in this unit, but let's go make sure that I have it in the right place and it's set up properly. Let's go to Applications, go down to 41, and there our application is. So it looks like everything is fine there. Next, let's go in and rename the first AGA3 tube to AGA3-1. Double click on it. Put the name in. Say OK. Next, let's go set up our communication link. We'll go to our XMV interface. Select Communications. In this area, we'll select how many XMVs we have in our application. In this one, we have just one, so we're just going to leave the one there. The port is COM2. Make sure you have your settings like I do in my setup. And everything should be fine there. Now let's go to the XMV setup screen. We'll select XMV. We'll need the following items set up. Modbus address is 1. Modbus register 21. Scan is enabled. We want English units. The rest of these settings are fine. Let's go to the Values tab. This is where we actually see our output from the XMV interface. Notice particularly differential pressure, static pressure, and temperature. These are the values that we want to be the source for our AGA3-2 tube, which is our second tube. So let's go there right now and make sure that those are set up correctly. 412050 is our differential. Let's go to the Advanced tab. And if we look over here, we can see that our units are set up correctly in the interface. The last and final item we need to set up in the XFC is our Modbus file. This file we're setting up is we are actually going to write multiple registers, the display information, and a flow rate to the Microflow. So let's go to the Save and Restore utility. We look under TF Data, XMV1. There's a Modbus folder there. Our file doesn't exist, so we're going to have to create one. Let's go up to Operate, File Utilities, Modbus Host Request Block Editor. We want to set up a Modbus function that actually writes multiple registers. Slave address 1 is correct. We're going to start at 8001, and we're going to write 4 different registers. The interval is fine. We're going to every 2 seconds. The source registers we need are from our second tube. The first one will be 12.7.0, which is our DP. Second one is 12.3.0. That's our static pressure. The third one is 12.3.3, which is our temperature. And the last one will be our flow rate, 12.7.19. Now we'll send this file. It'll ask us for a name, and we're going to call it X1T2 DISP. We're going to say OK. As you can see, we've now created the file. Let's double click on it and make sure that everything is fine. Looks like it is. This concludes the setup for the XFC. Let's begin the Microflow setup by looking at the applications. We'll go to the top menu, select the Applications tab. In this setup, we're going to need to make sure that we have the holding registers at application 9. And also it's normally set up for application 11 to have an AGA3 tube, but I went ahead and spared it out, or actually turned it off basically in this application already. So what you would simply do is, if it was already on, you would just simply spare it out to turn it off. And those are the two applications or two settings we need to make sure we do have. So let's send that. Do a reread. Looks like everything's fine there. Next, let's go to our COM port and make sure that we have all our communication settings correct. We'll pick the COM1 XMV slave. On the Setup tab, we'll have 9600, slave address of 1, 32-bit. Our protocol is Modbus slave RTU. That all looks good. Go to the Advanced tab. RS-45, 8, 9, and 1. These settings are okay for the timing. That all looks good. Next, we'll go to our holding registers and make sure that we have that properly set up. In holding registers, we're going to make sure to have 4 floats set up non-persistent. As you can see, I have that set up with descriptors turned on. That is correct. So now let's go to the display data. As you can see, I've already labeled 3 of them. Let's go ahead and call this last one flow rate. And send that. Let's do a reread to make sure everything's fine. Looks like it is. Next, we need to set up 2 MRM files, Modbus files, to map one the display information and the other one to map information for the XMV interface. So let's start with the first one for the display information. Let's go to our Save and Restore utility. Let's go to COM1, into our Modbus folder. And the file we'll be setting up, as you can see, I already have these set up, but let's look at it. Display MRM. I'll double click on that so we can view it. And what we have is, as you can see, the same holding registers we mapped right here will be mapped to the 8001 registers. So that's all that is doing. Let's cancel out of that. Let's look at the second one. This file has to do with the mapping of the inputs, pressure, differential, and temperature, to the 21 Modbus map. The XMV interface can look at this 21 register location and obtain these values. So that all looks good as far as the Microflow setup is concerned. Now that we've correctly set up the XFC and the Microflow and have connected them with the RS-45 communications, let's confirm their AGA measurement apps are populated with the correct flow data and communication is okay between the XFC and the Microflow. Let's connect up to the XFC. Let's go to the XMV interface. And we can see this screen here. It's usually a good idea to monitor this. As you can see, we have polls and errors. Looks like we have a lot of successful polls. So everything seems to be working fine there. Next, let's go to underneath XMV interface. Let's go to XMV1. Go to our values. We can reread this or monitor. Make sure we're getting good values here, and we do have success here in the status. Looks like everything's fine. Next, let's go to our AGA3 tubes. And we can do the same thing here. We can monitor. Make sure everything's fine with our inputs. Looks like it's okay for the first one. The second one, information coming from the Microflow. Looks like everything is fine there also. So it looks like everything's working properly in our setup. All information is coming in correct and good. This concludes our video. I hope it's been helpful to you. As always, we appreciate your interest in ABB Totalflow products. If you need additional help, the help files are a good place to go. We also have an application guide, 210-4264-001, that will also be helpful to you. Thanks again for listening.